That's one thing. Now to answer your specific question, thing is that the value that you saw in the TCP header when we were kind of discussing the header length in the wire search, it will be totally different actually from the value that you are seeing over here. Okay. The reason for that is that this is the data at the application layer. Okay. At the application layer, this is the data that was received by the browser. If we see this same data, on the wire search, we will see that in what you say in packet format, and that packet, and even like if you are seeing over here, like it's a one chunk of data that you are seeing over here, maybe in the packet this might be in the form of, like, let's say 20 chunks. Okay, so what I want to say is that tell you that the burp suit is showcasing, let's pick only one response header. Okay, let's pick up only one response header. So it is actually kind of giving you the content length of the data at application layer. Okay, now this data that you just saw in the burp suit might be, when you just do if you see that in the wire search, it might be at least, like, let's say 30 packets, and that packets will have, let's say, IP header, will have data link header, then it will have TCP header, then it will have the application data. Okay, so it will have a lot of other headers over there. Okay, and it will be like, let's say 30 packets. Okay, what burpsuit is doing is that it is able to just figure out this part, the application data, and this application data is something which is showcasing over here in the burpsuit part. Only this part, not this all things. Okay, and the other thing is that what it is also doing is that internally, the packets were of 30. It is consolidating all those 30 related packets into one. Okay, and it is showcasing that. So that application data that you are seeing right now over here might be in chunks in the packet. So maybe one chunk might have only this details, only this data. The other packet might have only this data. So it is high. The data in the packets will be something like this. The data will not be in one single packet, but it will be kind of in most of the time it will be in different. It will be divided into chunks. Okay, so maybe one of the packet has only this data. Okay, but when we are dealing with the burpsuit tool, what is happening is that all those packets are consolidated, and the data that we are seeing is only the application data over here. We are not seeing this all data. Okay, so that's the reason. Thing is that the header length will actually change. The header length that the burpsuit is telling you for this web server, but what the server has given you is the data that it has sent out only for the application layer. Okay, and this application data that you are seeing over here is actually combining the headers and as well as the data. Okay, so this data 5186 is the content length of this file, the HTML file. Okay, and it doesn't enclose, it doesn't hold the value of the content length of this headers. How to prove that? What I did is that I just copied this HTML file, what was sent out, and I saved that. And you can also kind of follow upon by doing it by yourself. So what I did is I just saved that in a text file, which you see over here. If I go to terminal, I just saved that in a text file e.txt. Okay, so if I just do cat e.txt, this is only the HTML file, and it is not having the HTTP headers. And if I just calculate the e.txt file, if you see, it's 5188. Okay, it is very close to the 5186 over here, because I have also copied few spaces over here, a few new lines. So that's the reason why it is 5188. It should be 5186. Okay, so it's the perfect example that this length is of the data of the HTML content, and it is not of this one. But because it would have also calculated the length of this one, the value would be something like 5210, something like that, but it not be 5186. Okay, so that's a kind of quick good example to kind of understand that this content length is of the actual data that was sent out by the web server, and it doesn't inculcate the content length of the headers that was sent out. Okay, so I hope this this content length is kind of easy to kind of understand. Is that any concern on this part, guys? Okay, now let's yeah. Okay, so now let's imagine how this content length, why we are interested in knowing about this content length and how this content length will be useful for us. So what again? Now let's see. Let's go to terminal, and now let's say you have the proxy log. Okay, you have the proxy log. So I will just say, let's say you have the proxy log, and let's say the content length is like, let's say for this one is 420, and I'll just kind of quickly, okay, so let's say its content length is 40, and let's say the content length of this one, of this packet is, let's say 54,000 for an example. Okay, and let's say content length for this one is 546, something like this. Okay, so let's say you have a proxy log and you want to kind of figure out what are those responses via the web server where the content length is quite huge. So let's say you are dealing with a malware case where the malware is actually downloading additional malwares. Okay, so maybe that additional malware size will definitely be something like, let's say something around 3 MB. Okay, 3 MB of file. Okay, it can be like that, 3 MB. So what will happen, how you can do is that to figure out where the kind of data, like upload that happened, like download that happened. So if we, from the HTTP headers, we want to figure out what were the possible download that happened of like huge amount of data that was downloaded, what we can do is that we can quickly go to the proxy log and tell the proxy log that showcase me all those entries where the content length is more than, let's say, 1,000. Okay, so in that case, what it will do is that it will quickly highlight only those fields where the content length is more than 1,000, and then what we will be able to do is that we will be able to figure out, okay, what are the websites, what are the systems which has downloaded certain additional file from the server. Okay, so this is one of the scenario where this content length can be kind of useful. It can kind of, it will be able to kind of highlight, are there any system who has downloaded huge amount of files from any particular web server. So that content length will be quite useful in kind of analyzing the proxy logs. So one of the thing that I can do over here is that, let's say this is the proxy log that I have. Okay, and I'm just kind of maybe what you guys can do is, let's say something like this. Let's say I have a Python file and I want to kind of analyze over here. So thing is that over here it is pretty difficult to do a grep. You can't do a grep over here that's telling that, okay, show me only those values, only those entries. I can do like grep, something like, okay, length. Okay, something like length. Okay, so it will showcase me all the values which has, or maybe let's say nano, just give me 1 second. Give me 1 second. So what I mean to say is, so there are two things. The first thing is that definitely what I wanted to say is that the proxy log will be very useful to kind of know for any incident, are there any kind of system who has downloaded a huge chunk of file from the web server. Okay, let's say you have the web server ID, which is like the malicious domain URL, and you wanted to know, are there any systems which has downloaded additional malware from that web server, downloaded additional malware from the malicious web server. Okay, so in that case, what you can do is that you can just review the proxy log, and you can see, okay, are there any entries where the content length is, let's say, more than 1000?